the purpose of Laplace transform. Okay, and then you know how to transform. Okay, there are methods to transform which are by definition and also directly from the table. Okay, once you can transform, you need to understand the properties of transformation. Okay, so how many properties that we have learned so far? And what are those? Okay, 3. First one is what? Linearity. First shifting. Another one is multiplication by t to the power of n. Okay, so remember, for the properties of Laplace, we are going to have second shifting after this. So you need to know the difference between first shifting and second shifting. Okay, so right now we have done with 3 properties where linearity involved with the addition, subtraction, and scalar multiplication. Okay, first shifting involved with the exponential function multiplied by ft, and multiplication by tn is involved with multiplication by t to the power of n with a function of ft. So when we have a certain type of function, how can we transform? Okay, so but basically we can always transform one by using definition or directly from the table. Okay, so that one just for revision. Okay, so as for today, we are going to transform a special types of function, and we are going to further a little bit more about the properties. Okay, so this is one type of a special function that you need to know how can you transform. Okay, so before we find the Laplace transform of Heaviside function, okay, now we want to transform a Heaviside function, or we can call it as a unit step function. So before we find the Laplace transform of this function, okay, let us discuss the definition. Okay, so what is Heaviside, or what is unit step function? Right, so the unit step function is defined by ht minus a. So this is unit step function or Heaviside function. Okay, the definition is given by ht minus a here is of course a function of ft equals to 0 when t is from 0 to a, and equals to 1 from t greater than or equals to a until infinity. Okay, so if we want to illustrate this function in terms of graph, then you know the function here from 0 to a, it is equals to 0 here. And from a onwards to infinity, okay, it equals to 1. So this one 0 for 0, for t from 0 to a. Okay, so this is definition of Heaviside function. So now, remember, in our previous example, we have transformed a piecewise function. Okay, how can you transform a piecewise function? By definition, you transform one by one, you integrate one by one according to the definition of Laplace. But now, by using this Heaviside function, okay, by using this Heaviside function, we can form a step function, which is also called as a piecewise continuous function. So instead of transforming one by one of the piecewise function that you have done in the previous example, okay, the step function here can be expressed into unit step function, right? So previously what we have done, we transformed a piecewise function one by using definition. But now you know that this piecewise function is also called as a step function. Okay, this step function can be expressed into unit step function. So why we express to unit step function? Because we want to transform. Okay. So how can we transform? Okay, let's wait for that. So now, how can we convert the unit step function, from the step function to unit step function, or from unit step function to step function? Understand or not? Clear or not? Anyone has question? So this is a piecewise function, okay? The general form of piecewise function, which was done previously by definition, okay? But now this piecewise function are also called as a step function, and it can be expressed into unit step function or Heaviside function. So what is unit step function or Heaviside here? This one. Okay, so now our purpose here, you know that this is piecewise. You want to convert this piecewise or this step function to unit step function. So how? Okay, how can we convert? So is that clear or not? The difference between step function and unit step function. That one first. Can you differentiate between those two? Any question? Okay, understand. Okay, now how can you convert? Only Li Zong understand? What about the rest of you? Are we clear about this? The difference between unit step function and step function. Okay. All right, so how can we convert? Okay, now you consider this. This is step function. Why you know that this is step function? Because we have function here. The difference between step function and unit step function is the unit step function has 0 and 1. Unit, okay, it is a unit. So in step function, it is in terms of function. Okay, so how can we convert this step function to unit step function? Okay, now, so first factorize the function. You put g1 outside, so g1 plus 0 will give you g1, right? So you put g1 outside, g1 here, so g1 plus with 0 equals to g1, and g1 plus g2 minus g1 equals to g2. So you just factorize this g1, put it outside, and then this g2, make sure minus with g1 because we have g1 here, okay? And then factorize again this by putting this g2 minus g1 outside. So now here you have 0 and 1, where this is a unit step function. So in terms of step function, now it become unit step function. Okay, this one. Sorry. So instead of G1, G2, now it becomes G1 plus G2 minus G1 times with 0, 1, 0 from T from 0 to A and T greater than A, where this form can be simplified to HT minus A, this one, unit step function. Clear or not? Understand or not? Anyone has question on how to convert? Faham tak? Any question? Understand?
Okay.
Okay. So now let's try this example. We have this step function. So this is step function. You want to express in terms of unit step function. Okay. So basically what you have to do is first put t minus 4 aside so that you have what? T minus 4. Okay. And then plus, as you can see here, first G1 is this one. And then G2 minus G1. G2 is T, right? T minus T minus 4. Okay, then HT minus A. So 0 to 2, 2 to 4. So here we have HT minus A. Here is 2. Okay. Plus, because we have 3 terms here, then we should have G3 minus G2. So plus G3 is 0 minus G2 HT minus 4. Okay, so now the function now can be expressed to unit step function by T minus 4, T minus T minus plus 4H T minus 2, T minus T plus 0 minus T, so minus T H T minus 4. So this is the unit step function. Okay, clear now? Understand or not? From the step function, now we change to unit step function following the form here we have. Okay, it is proven here. So now we have up to 3 functions. So you should have here up to G3. Okay. Okay, understand? Are we clear?
Yes, sir.
Alright. So that is how you express or you convert the step function or unit, or piecewise function to a unit step function. Okay, so now let's try to convert a unit step function into step function. Okay, so here we have unit step function. This is in terms of unit step function already. So now we want to change to step function. And you know, in order to have this, we have what? We have Ft equals to G1 plus G2 minus G1 H2 minus A. We have up to 3 terms, so G3 minus G2 HT minus B. So just identify the form. So G1 is T plus 1, right? And then G2 minus G1 here is 1 minus T. So substitute what is your G1. So G2 equals to 1 minus T plus with G1. Okay, which give you what? 2. Alright, and then G3 minus G2 here equals to T squared. And you know that what is your G2? G2 is 2. So you can write in the form of a unit of a step function. G1 is t plus 1. G2 is 2. G3 is t squared plus 2. So now in terms of a range. So here t minus a. So it starts with a is 2. So following the form in general form here, we start with 0 to 2. Okay. And then this one. What is b? b is 4. So here you know that it is greater than 4. So now 2 for G2 is t from 2 to, okay, clear? Understand? Anyone has question for this part? You need to know this process first before we can transform the unit step function from step function to unit or from unit step function to step function. All right, clear now? So the idea here is to use this formula, where this formula comes from here. How we convert one by one here. So no need to do one by one as long as you understand the process of conversion in the formula here. Okay, clear? Any question for these two examples? All right. Okay, good. So that is how we express. Now, how can we transform? How can we transform a unit step function? Okay. So you can take a look at your notes where the transformation of Laplace transform of unit step function, where unit step function is ht minus a, is given by exponent to the power of negative es over s. Okay, so let's prove this. You know that ht minus a, the unit step function, is given by 0, 1, okay, from 0 to a and a onward. Right? So, by definition, if you want to transform the function, it is always integrate from 0 to infinity exponent negative xt times with ft dt. So, here you have 0 to a, right? We start with 1 with 0 here. So, exponent negative st multiplied with 0. Okay, integrate with respect to t, plus integrate from 1 to infinity. Integrate what? Exponent minus st times with 1. Integrate with respect to t. So this is how we integrate the piecewise function like we did previously. So this one is 0. Okay. So let's focus on this part, which equals to what? Minus 1 over s, 1 over exponent st, integrate from 1 to infinity. So just substitute. Okay. So we have negative 1 over s. Sorry, this is a, right? So 1 over exponent a infinity times with t times with s, so infinity, minus with 1 over exponent as, which equals to, this one is 0. So negative 1 over s times negative exponent as, which equals to exponent negative as over So this is why the transformation of ht minus a equals to exponent negative es over s. Okay, clear? Any question? Okay, doctor. Okay. All right. So now how can we transform? Once you know how to transform by using the properties of a unit step function, then the transformation becomes easy. No need to transform by definition one by one like this, just like we did in piecewise function previously. So let's take a look at example 10. How can we transform this? Okay. Find Laplace transform of ft if ft is ht minus 2 minus ht minus 4. So first, you want to transform this ft. Okay, so by using linearity property, you just can separate this one by one. Okay. So by the definition of transforming a unit step function, you know that your a equals to 2 here. Okay. Sorry, this one is 4. And this one is 4. So transforming this, ht minus a becomes exponent negative es over s. Now ht minus 2 becomes exponent negative 2s over s minus ht minus 4 becomes exponent negative 4s over s. Okay, so simplify, then you can have the transform version of this ft. Easy, right? So this is how we transform a unit step function. Any question? Okay, good. All clear. So next, you know how to transform a unit step function. Now we introduce another property. Okay, where we apply our second shifting property. So in second shifting property, it is mentioned that ft minus a multiplied with ht minus a is given by exponent to the power of negative as transform ft, and you have exponent negative as fs. Okay, let's prove this first. Okay, so first you know ft minus a ht minus a equals to what? Equals to ft minus a multiplied with the unit step function 0, 1. Okay. Now you want to transform this ft minus a, ht minus a. By definition, it is always integrate from 0 to infinity exponent negative st times with ft dt. And you know your ft here is ft minus a, ht minus a. So integrate one by one. So from here, you know that it starts from 0 to A. Ft minus, sorry, exponent negative St, Ft minus A times with 0, integrate with respect to T. So here times the definition, plus integrate from A to infinity, exponent negative St, Ft minus A times with 1. Okay, so now we just can integrate one by one. So this one is 0. Okay, so now let's focus on this part. So how can you integrate this? Okay, let's try substitution. Let u equals to t minus a and du equals to du dt equals to 1, so du equals to dt. Okay, so if u equals to t minus a, so t equals to u plus a. So substitute here. Then we have integrate from this one is t, right? Okay, this one is t. Now we want to convert to u. So when t equals to a, then u equals to t minus a. So u equals to a minus a, right? And then this one, infinity, still infinity. This one, u equals to infinity minus a, still become infinity. This one is 0. Okay, now exponent negative st is exponent negative su plus a, because t is u plus a, and fu du, right? So here we have 0 to infinity, exponent negative su minus sa times with fu du. So this is with respect to u, then we can put this exponent. Okay, before that, so this one we can simplify. So this is a constant because there is no u, then we just can put it outside. Okay, as you can see, this is the definition of Laplace transform. So this is how we transform ft minus a, ht minus a. Okay, so by second shifting property. All right, clear now? Okay, understand? This one is identical with the definition of Laplace transform. Okay. So if exponent negative st ft with respect to t is fs, now exponent negative su fu with respect to u is also transform version of t becomes fs. Okay, so now this is proven. So how can we implement this property? Okay, now let's take a look at the example. Okay, example 11. Transform t minus 4 squared h minus 4. Okay, so you know that this is method transforming ft minus a ht minus a. Okay, where you know that ft minus a equals to t minus 4 squared. ht minus a equals to ht minus 4. And you know this one, you have to make sure that if this is A, this one is also A. So this is 4, this is 4. Then A is 4. If you have, if you don't have similar value of A here, you need to do some adjustment. Okay. But now we have a similar value 4 and 4, then we can say that A equals to 4. Okay. When ft minus a equals to t minus 4 squared and a equals to 4, then what is ft? What is ft? Anyone want to try? Okay, so ft equals to t squared. When ft equals to t squared, what is fs? By transforming t squared, we will have what? From the table, how you transform t to the power of n. Now we have n equals to 2. So you should have what? Look at the table of transformation. Okay, so 2 factorial over s cube. So 2 factorial is 2 over s cube. Okay, so you have your A, you have your Fs, then transforming t minus 4 squared ht minus 4 map to transforming ft minus a ht minus a, which become exponent negative es fs, which is exponent negative 4s times with 2 over s cubed. So we have 2 exponent negative 4s over s cubed. So this is your transform function of t minus 4 squared ht minus 4. Is that clear? Okay, so by the way, is there anyone who still has problems in understanding factorial there? Factorial is a value, right? Okay, clear not? Any question? Okay. So now let's try another one. All right. So you can see here, this is also mapped to f t minus a h t minus a. Okay. But here we have plus. So we should do something here. Okay. So we should do something here in order to make sure that it is in the form of t minus a and t minus a. Both should have t minus a and t minus a. Okay. So just in our previous example, it is in the form of t minus 4 and t minus 4. So we'll just make sure that both has a same term. But now it is t minus pi over 2. It is t plus over pi over 2. So it is not same. So you have to change this. So now cos 2 t plus alpha over 2, okay, should be in the form of ft minus alpha over 2. But this one is t plus over 2. Okay, so we can have some adjustment here where you know that cos 2 t plus pi over 2 is equals to cos 2 t minus pi over 2 plus 2 pi over 2. So this one comes from what? This one comes from 2 pi over 2 here is just an addition term in order to make this pi and this negative pi over 2. So we just create this so that we can reduce that positive pi over 2 there. So if you want to simplify this, it is 2 pi over 2 minus pi over 2 becomes plus pi over 2, right? Understand or not? We just create this. So this t plus pi over 2 is actually can also be written as t minus pi over 2 plus 2 pi over 2 because we want to create this t minus pi over 2 so that we have to make a similar term with ht minus pi over 2. Okay. And from here, what you can do here is expand this. So this one becomes 2 t minus pi over 2 plus 2 pi, right? So this one, so we have here an identity of cos A plus B, which equals to what? Cos A cos B minus sin A sin B. So we can deduce this by identity. We can deduce this cos 2t minus pi over 2 cos 2 pi minus sin 2t minus pi over 2 sin 2 pi. Okay, clear? Clear now? So this one is 0. This one is what? Cos 2 pi is what? 1, right? So you can write cos 2 t minus pi over 2. Okay. So now you can reduce to right, as you can see, it is in the form of t minus a, where a is pi over 2. What is your ft minus a? Ft minus a is cos 2 t minus pi over 2. So, what is your ft? Ft equals to cos 2t. So, when ft is cos 2t, what is your fs? By looking at the table of transformation. S over S squared plus 4, right? Alright, okay. So you have your A, you have your Fs, then this one will become exponent negative As Fs, which equals to exponent negative pi over 2s times with s over s squared plus 4. This is how we transform. Okay, clear or not? Anyone has question? So usually in trigonometry, if you want to reduce the function, we can always use the identity. Okay, so what we have been learned so far is first a unit step function, and then you convert step function to unit step function, and then you know how to transform a unit step function, which is exponent negative es over s. Then by second shifting property, when the unit step function is combined or is multiplied by another function of ft minus a, it is equals to exponent negative es fs. Okay, so up to now we still focus on unit step function. So this property is applied to unit step function. Clear or not? Up to this example, up to this point. Anyone has question? Okay, so from 1 to 10, where are you?
7.
6, 6, 6, 6, 6, 5. It's okay. Still a number. You still have the value there. All right. Understand? If you understand what we have been learned so far, okay, why don't you try this example? First, this is step function. Express this function in unit step function and then determine the transform. Okay, try it. After this, we discuss. Transform the function first before you, sorry, express the unit step function first before you transform. Decoding. Okay, any question? First, what we did here is convert the step function, this one, this function, convert to step function. Okay, so this is your unit step function. Okay, what now you want to transform. Okay, you want to transform, Laplace transform of this unit step function. And this unit step function has 4 plus 2 minus 7 ht minus 2. So by linearity, you just can separate these two expressions. Okay, to A and B. So you just transform one by one. Transforming A, 4 here will give you 4 over S. Transforming B here is mapped to ft minus A, ht minus A. But you have to make sure that both function of f and h must consist of t minus a. But here we have to t minus 7. So we need to do some adjustment. So instead of 2t minus 7, instead of t itself, we create t minus 2 and we should plus with another value just to make sure the value of the expression is not changed. So if you have t, then you change to t minus 2. If you expand, you will have to t minus 4. So to get minus 7, you should just minus 3. Okay, you should just put minus 3 there in order to remain the minus 7. So now this 2t minus 7 is now um, changed to 2t minus 2 minus 3. So the process of transformation now is 2t minus 2 minus 3 ht minus 2. But we have remained t minus a and t minus a, where a equals to 2. When a equals to 2, ft minus a is 2t minus 2 minus 3, then you know that ft is 2t minus 3. So from here, by linearity also, we can transform this one by one. Transforming t will have 1 over s squared multiplied with 2, you have 2 over s squared. Transforming 3, you have 3 over s. So this is your fs. Okay, and you know when it is mapped to ft minus a, ht minus a, by second shifting, it is exponent negative as fs. So just substitute what is your a and what is your fs. And remember, you have to combine all a and b as the product of transformation of the whole function here. Okay, is that clear? Anyone has question? Okay.
Okay, doctor.
All right. Okay, let's try another example. Okay, try this. Can you see it? First, express the function in terms of unit step function and then find the Laplace transform. Okay. Anyone has question regarding on this? All of you got this? You know how to do it or you have problems? Anyone has question regarding this? let's proceed again. Before our long break, let's just proceed with another topics, direct data function. Okay, so now for direct delta function, this is another special function other than unit step function. Okay, so the difference between their direct delta function is and unit step function is only this and the range. Okay, so in unit step function, we have what? We have 0 and 1. Okay, but in direct delta function, it is equals to infinity when t equals to a. Otherwise, it is 0. Okay, and if you integrate direct delta function from 0 to infinity, it is always equals to 1, right? And if you integrate ft times with direct delta function t minus a here, it is always equals to fa. Okay, so by using this definition of direct delta function, we can transform this this delta t minus a, okay, or delta t only by using the properties of direct delta function here. So how can we prove this? All right. So let's prove direct delta function transformation here. Okay. So let's prove direct delta t minus a first. Okay. By definition of Laplace, you know that we have to integrate from 0 to infinity, okay, exponent negative st delta t minus a with respect to t. And you know that this exponent negative st here is just a function of ft delta t minus a. And given by definition, if you integrate from 0 to infinity of ft delta t minus a, it is equals to fa. Now, ft equals to the exponent negative st. Then, fa equals to exponent negative as. So this is how we prove, how we obtain here. Okay, same with delta t. So if you want to transform delta t, means that your a is 0. So that's why exponent negative as is exponent to the power of naught, which is equals to 1. Okay, this one. Same process with this, the proving process, but your a here is 0 for delta t. So just substitute a here with 0, then that's why we have 1. Okay, and then another one, transforming ft delta t minus a. Okay, we integrate exponent negative st ft delta t minus a. Okay, so let's say let our gt equals to exponent negative st ft. So now you have 0 to infinity gt delta t minus a. Okay, which equals to what? This one will give you what? Will give you GA. So if GT is exponent negative STFT, then GA equals to exponent negative ESFA. So this is it. Okay. So this is how we prove. So the definition of direct delta function here is important for us to prove the transformation process of this direct delta function. Is that clear? Any question? Clear not? Anyone has question? All right, guys, are we good? Okay, so let's try example. Let's try our example. Okay, you want to try? The first one is what? The first one is easiest here, where you first apply the linearity property. Okay, transforming exponent minus 2t plus transforming a direct delta function of t minus 2. Okay, so here you should have what? By looking at the table of transformation, exponent as will have exponent s plus, 1 over s plus 2. And direct delta function dt minus a, delta t minus a. So we have here plus exponent negative 2s. That's it. This is your fs. Okay, clear? Okay, clear not? Very easy, right? Okay, then next one. So looking at the properties of transforming direct delta function here. So this example map to ft and delta t minus a, right? Where your a is pi over 2. Am I right? And your ft is T cube. So when Ft is T cube, then what is your Fs? Sorry, no need. Then what is your Fa? Because we have here equals to what? Equals to exponent negative as Fa. So you need to identify your A and your Fa. So when Ft equals to T cube, A is pi over 2, then Fa is pi over 2 cube. So the transformation becomes exponent negative pi over 2s times with pi cube over 8. Okay, so just follow the definition there. And when you have Ft delta t minus A, the transformation becomes exponent negative as Fa. So you identify what is your A, what is your Ft, and then find Fa and then substitute. Clear? All right, try example 16. The same mapping. We have sine 2t and we have delta t minus A. This is your Ft. This is your delta t minus A. Identify your A and your Fa. This is very easy. All right. So what is the transform version of this? Exponent negative to s sine 4. Okay, good. So the transformation become exponent negative to s sine 4. Okay, clear? For today's lesson, are we clear? Unit step function to step function or step function to unit step function, transforming unit step function, use the second shifting property in unit step function. Now we transform direct delta function. So the difference between ft delta t minus a and ft minus a ht minus a is you don't have to standardize the t and t minus a here. Okay. Compared to second shifting, you have to make sure that both expression has t minus a. After that, you can use the property. Okay, everything's good from 1 to 10. Where are you now? Which exercise? Is it in the notes? Past year, is it? Right. Okay, last one for today. Another one. This is just the transform function. Okay, so we have done with transforming. We have done with transforming functions, special types of function, apply the properties, right? Okay, so you know that we need to transform everything first, and then you find the solution, and we inverse transform, then we can find the solution in differential equation, right? You get the whole story behind of this transformation. So before we proceed with inverse transform, you need to know how can we transform the derivative. Okay, so this is just the knowledge. Okay, after this we are just going to use this, no need to prove, but this is just for additional knowledge. Okay, and of course in differential equation we always has y prime, y double prime, and so on, right? So by using a Laplace transform, you still need to transform the derivative form. Okay, so we will see the use of Laplace transform here to solve the differential equation. Okay, but before we are going to find the solution of the function in S domain, you need to transform every differential. Okay, given in the differential equation. So to solve the differential equation by Laplace, we will go through 4 distinct. We have to rewrite the function in terms of Laplace, apply the condition, and so on. So this one we're going to discuss later, but I'm going to discuss here today how to transform the derivative. If you have y, okay, before this, you have ft, the transform version is fs. So if you have yt, the transformation is ys. Okay, now if you have y prime, the transform version is sys minus y naught. Okay, so how can we prove this? So if you have y prime, then you want to transform y prime here. Okay, so of course we apply the definition. Exponent negative st, ft now is y prime t. Okay, so here is a function of t, here is a function of t. You can use tabular method or you can use integration by part, right? So you can have here exponent negative st yt plus integrate from 0 to infinity se minus st yt dt. Okay, so uv minus v du. All right, then just apply the condition, the limit here. Okay. So this is how we obtain the transformation. So as you can see, this is the definition of Laplace, and both are function in terms of t. So you need to apply the tabular method or integration by part. And then apply the limits, then you can get this. Same apply to the rest of the derivative, but no need to prove. Okay, the proving process here only for your additional knowledge. But you have to know the transformation of y prime becomes sys minus y naught. Y double prime is s squared ys minus sy naught minus y naught prime, and so on. So we are going to use all of this in solving the differential equation later. Okay, so that's it. We have done with the topics for today. Any question? Everything's good? As I can see, the number is increasing here about your understanding. I hope you can understand all of the topics today. Okay, so don't forget, even though next week is your Hari Raya holiday, your test 1 should be on 9th May, okay, which will cover up to method of undetermined coefficient, excluding the application of first order ODE. Right, so if you have no more question, I think that's it for today. You can stop. Okay. Any question regarding your topics today or your upcoming test?